All right, welcome everyone. We're diving into the key ideas from Google's really cool Kaggle course on AI agents, and we're starting with a massive shift in thinking, moving away from an AI that just talks to an AI that actually does things.
So let's just kick things off with this fundamental question. For years, AI has been this kind of passive partner, right? We give it a prompt, it spits back an answer. But what if we could flip that script? What if an AI could understand a goal, sketch out a plan, and then, actually take action in the real world to get it done, all by itself? That is the huge leap we're talking about today.
And this slide just illustrates that difference perfectly. Over on the left, you've got your standard passive AI. You ask, hey, what's the weather in San Francisco? It tells you 65 degrees and sunny. Super useful, but that's where it stops. But on the right, that's Agentic AI. You give it a goal like, plan my weekend trip to San Francisco based on the weather. That AI doesn't just give you a one-line answer. It's going to check the forecast, find some cool activities, maybe look up ticket prices, and come back to you with a whole plan. It's a problem solver, not just a talking encyclopedia.
So, how in the world do we build these problem solvers? Well, to get it, we need to look at their anatomy. The best way to think about an agent is that it has three core parts: a brain that does the thinking, hands that can take action, and a nervous system that connects everything together. First up is the brain. This is the large language model, or LLM, and it's the core reasoning engine. Its most critical job, really, is to manage what's called the context window. Think of it like the model's short-term memory. It's constantly looking at its mission, its past actions, the tools it has, and deciding, okay, what's the most important piece of information for the very next thing I need to do?
But a brain can't really do much without hands. And for an agent, its hands are its tools. Think of these as its connection to the real world. An API to check your calendar, a function that can search a database, maybe a script that sends an email. This is how the agent breaks out of just generating text and starts actually doing stuff. And the thing connecting that brain to those hands is the nervous system. We call it the orchestration layer. This is basically the conductor of the whole symphony. It's managing the agent's main loop, it's keeping track of memory, and it's making the crucial decision of when it's time to stop and think versus when it's time to pick up a tool and act. It really governs the entire process.
Okay, so how do these parts actually work together?
Well, they run in this constant cycle. Let's take a simple example. A customer asks, where is my order? First, the agent gets its mission. Then it scans the scene. It sees it has a tool, an API, to check the order database. It thinks, okay, first step is to find that order. It takes action by calling the API. Then it observes the result. Let's say it gets a tracking number. And then it iterates, thinking, okay, I've got the number, what's next? This think, act, observe loop. That's the fundamental heartbeat of every single agent.
Now here's a key point. Not all agents are created equal. They actually exist on a spectrum of capability, and we can break that down into 5 distinct levels. And understanding these levels is absolutely critical if you're trying to decide what kind of agent you actually need to build.
It all starts at level 0, which is basically just the core LLM by itself. All reasoning, no connection to the real world. Level 1 gives it some tools, letting it access live data. Level 2 is where it gets strategic and can do multi-step planning. Then at level 3, things get really interesting. You see teams of specialized agents working together. And way out on the frontier, at level 4, you have these self-evolving systems that can literally create their own tools and agents to tackle brand new problems.
So, that big leap to a strategic level 2 agent? That requires a whole new skill, something called context engineering. It's basically the art of strategically managing what the agent pays attention to. Just like the quote says, the agent's accuracy really depends on having a focused context. It's all about feeding the model exactly the right info at the right time without drowning it in a bunch of noise.
And here's a perfect example of that in action. The mission is to find a coffee shop halfway between 2 addresses. A smart level 2 agent first acts by using a maps tool to find that halfway point. It then observes the result it gets back: Millbrae, California. Then, and this is the brilliant context engineering part, it thinks, and then it acts again. But this time, it uses that new piece of information, Millbrae, to build a brand new, super focused query for a different tool. See what it did? It used the output of step 1 to intelligently create the input for step 2.
Okay, this all sounds incredibly powerful, right? But how do we actually make these agents reliable and, more importantly, safe enough to use in the real world? This brings us to the really practical challenges of agent ops and security.
Testing an agent isn't at all like testing traditional software. You can't just check if the output is exactly one specific string of text.
Instead, agent ops is all about evaluating the quality of the outcome. A really common technique is to use another powerful AI, an LMS judge, to basically grade the agent's work against a detailed rubric. So you're not asking, is it perfect? You're asking, how good is it really?
And of course, whenever an AI can take action, there's risk. There's this fundamental trade-off. The more useful and powerful an agent is, the more potential harm it could cause if something goes wrong. That's why security has to be a defense-in-depth approach. This means you need a mix of things. Hard-coded rules, like spending limits, combined with AI-based guard models that are constantly watching for risky behavior before it can happen.
So, where is this all going? Well, the future probably isn't about building one single all-powerful super agent. It's much more likely that it's about building a team of specialists. It's about collaborative, multi-agent systems. Google's Co-Scientist project is just a fascinating glimpse into this world. It's a level 3 system where you have a supervisor agent that gets a really complex research goal. But instead of trying to do all the work itself, it acts like a project manager. It delegates specific tasks to a team of specialized agents. One to go read the research, another to analyze data, a third to come up with new ideas. It's literally mirroring a human organization to solve incredibly hard problems. All of this points to a fundamental shift in our own roles. As creators, we're evolving. We're moving from being coders who write every single line of logic to being more like directors who set the scene, pick the right cast of tools, and then guide these increasingly autonomous AI teams. So that really just leaves us with one final thought to chew on. What will you ask your AI team to accomplish?